In this part, we are going to introduce the graph neural networks for recommendations. And the existing recommendation methods follow a general supervised learning paradigm. That is given the user item interaction matrix. First, we transfer each interaction into a separate data instance. And second, we feed this instance into a supervised learning model to perform the predictions, including the representation learning and interaction modeling. Here, we normally will use the neural networks to achieve these two steps. However, such a general paradigm treats each observations as an independent instant and ignore the implicit and explicit relationships among the instances. And we call this as the information isolation issue. In fact, there exists a potential relationships among the users and item. For example, there are behavior similarity among the users and items. And this adoption of the information isolation in such paradigm overloads the relationships among the instance, which may result in the suboptimal performance. On the other hand, data in recommender systems can be data in recommender systems can be representative as the graph structured data at many user-based online servers. The first one is the key graph, the main graph. We call it the user item graph, denoting the interactions between the users and items. The second graph usually exists in the social network size. We call it the user-user social graph, denoting the relationships between users. And the next one is the item graph, denoting the substitutable and complementary items, or the item internal knowledge. Okay, considering the data of recommender system as graph can provide a great opportunity to explore and exploit the relationships among the instance, so as to alleviate the information isolation issue. Then here is the question: how to model such graph structure data while still achieving the promising performance for recommender systems? And one of the potential solution here is to consider the data of the recommender system as a graph and employ the power of the graph neural network techniques to explore and exploit the relations among the instances in the graph. So first, what is graph neural networks? Recently, the graph neural network techniques have achieved great promising performance for the graph data by learning the meaningful representations. The main idea of them is iteratively aggregating feature information from the local neighbors by using the neural networks. At the same time, the node information can be propagated through a graph after the transformation and aggregation. So as you can see in this figure, the graph neural networks can naturally integrate the nodes information and as well as the topological structure. So given this advantage, graph neural networks provide the great opportunity to alleviate the information isolation and advance the recommender systems. Here is the description of how a graph neural network will work. So let's think of the following. For each node, we will have a representation, and the super subscript tell us at what level of the neural network and the operation. So at the level zeros of the neural representation for the node V, is similarly the node's feature vector. Then this will be the inner layers of the neural network. And we will have a representation for a given node at each layer. And then the representation of the final layer of the neural network is our final embedding of the node. Now, we need to explain what is happening. Here, the sigma is the non-linear iteration function, like the value. That is the thing that people like to use the most. And now, what is happening here? What we are doing here is to compute the representations for node v's at the layer k. And let's go through the neighbor of the node v and take the representations of the neighbor from the previous layer k minus 1. Then we can average this together. And this is the most straightforward aggregation operation. So essentially, what I am saying here is this is the node v and node v, and we check who are the neighbor of v's neighbor at the layer k, and then we take their message, and average them together. And note that we have two weights here, the parameter matrix. Note that we combine this message from the neighbors, this part, with the message from itself from the previous layer. So this is what happens here. Okay, there are other variants, GNN models. The two represented GNN model, that is the GraphRec and the GAT. This part was the type of aggregation we just introduced things before. Now the GraphRec use a general aggregation function. And here, what kind of function we can use? What we did before, we was simply using the mean aggregation function, right? And we simply take the message from the neighbor and add them up and do the normalization by the number of the neighbors. This is the most straightforward aggregation function. And we can also do the pruning approach. For example, we can do the element-wise mean or mass pruning. So that would be another operation. And last, if you like, you can even use a neural network, like the LSTM, to able to learn how to aggregate the neighbors. And the purpose of using the LSTM is to reshuffle of the node. Another representative GNN model is the GAT, so for the graph attention networks. The GAT implicitly assigns the different weights for different nodes. In the target node's neighbors, here the alpha RU VU is a nullable attention weight, indicating the importance between the node V and the node U. And for more about the graph neural network techniques, you can refer to the book Deep Learning on Graph by Yao Ma and Professor Jilian Tang from the Michigan State University. And you can even download the ebook via this following link or scan this QR code. And let's go ahead. Now, we are going to introduce some representative graph neural networks based recommendation methods. Here, we will introduce recommendations with three categories. So the first type of recommendation methods purely focus on the user item interactions, which means we do not have any other side information for the users and items. And the other two are the graph neural network-based recommender systems, with some side information enhanced. And this kind of side information and can be the social network in white. Then we call it the social recommendation, which can use the social relations to help learn the user embedding or the item internal knowledge information, and which can enhance the item embedding learning. Okay, let's first go ahead to the GNN-based collaborative filtering methods. Given the user item interaction matrix with the 1 and all zeros, we can easily induce a bipartite graph with the user nodes and the item nodes. While there are other scenarios, we can have other types of interactions. Can be the weighted interaction matrix. Denoting this denoting the weighting score given by the users to the target items. And let's say in the movie recommendations, right? We can have a 1 to 5 star weighting systems. And 1 represent I hate it, 3 is neutral, and 5 as I love it, right? And so in this case, we have the bipartite graph with the weighted age. And how to model this kind of the weighted interaction matrix. One of the most representative method is the GCMC, short for the graph convolutional matrix competition. So to learn the user representations in this scenario, GCMC first aggregate the neighbors information for each value R. Here, this model adopts the learnable weight WR to make differentiations for a specific weighting value R. Then this method accumulates all the weighting specific representations to finalize the user representation for each user. Likewise, the item representations can be learned in a similar way. Another representative model is the NGCF, which was proposed in IR 2019. Here, in this paper, the authors propose a novel framework, the neural graph collaborative filtering, to exploit the high-order connectivities in the user item graph by the embedding propagation. Here, the U1 is the target nodes. Then we have the implicit or explicit link in this user item graph. They use the embedding propagation to enhance the user, the target user one's embedding learning. Here, for the user node, they first compute the aggregation information from each neighbors in this equation, and learns the collaborative signal. And then they refine the node embedding based on the aggregated information at each such embedding information. At last, we can get the final node embedding by concatenating the node embedding from different layers, as shown in this equation. And although the NGCF have shown a promising results, some researchers argues that there exists unnecessarily complicated designs in this GNN model for the collaborative filtering. And this model is the Night GCN, which was proposed in IR 2020. They empirically found that the feature transformation and the nonlinear iteration function may contribute little for the recommendation task. Therefore, they propose to simplify the design of the graph convolutional network and propose to unite the graph convolution and the night a near combination for the recommendation. More specifically, the GGCN learns the user and the item embedding by the linear propagation, by linearly propagating the terms on the user item interaction graph. And then they use the weighted sums of the embedding learned at all the layers in this model to do the prediction. And to sum up, they just remove the feature transformation and the nonlinear activation in the NGCF model. While in real-world recommendation scenario, there are actually not only just the user item interaction. There actually exist lots of other informations about the user, especially in the social network side. We can have which the social relations, and this kind of social relations are very helpful for the recommendation task, especially in the case of sparsities and the star co-star users or items. So here in next part, we will introduce some representative paper focusing on how to incorporate the social relations into the solution for the recommendation task. So in addition to the user item interaction, social relations among the users provide another stream of potential information for understanding users' preferences. It based on the idea that the users can acquire or disseminate the information through their social relations, like the classmates, friends, and so on. And to put it another way, and users' preference are similar to or can be influenced by the people around them. And we call this type of methods social recommendation. Let's take a look at this example. And you can see that some user prefers to watch the drama movie, while others like the action films. It suggests that users in the same group are more likely to share similar preferences. Okay. On the other hand, the data in social recommendations can be representative as the graph data, with the user item graph and the social user social graph. Here, moreover, the users bridge these the user item graph and the social graph. In other words, we aim to utilize both graphs for the item and the user's representation learning. So in this slide, we're going to introduce the GraphRec model, which was proposed in the WW 2019. And this is one of the most representative GNN-based recommender systems. And basically, this model, GraphRec, consists of three main components: the user modeling, item modeling, and the weighting prediction. The user modeling aims to learn the user representation, and the item modeling is used to learn the representations about the items. In particular, here we focus on the user modeling part. They utilize two different aggregations to respectively process these two different graphs. One is the item aggregation, which is used to understand users based on the historical interactions with different items in the user item graph. And the other aggregation is the social aggregation for learning the relationships between the users in the social graph, and which can help model the users from the social perspective. And let's take a look at the social aggregation. In the social graph, the strong and weak ties between users are mixed together. What does it mean? That means the users are more likely to share similar tastes with the strong ties than with weaker ties. So the GraphRec introduced an attention mechanism, attention network, to model the exchange between the user ties with the neural networks. And this attention way, look at this formulation, is the beta, can be seen as the strength of the tie between the users. Here, the social aggregation can be formulated to aggregate the item space user latent factors from the user's direct neighbors. And the NI means the user I's social neighbors. And the output here, HIS, is the social space user representation of the user I. Okay, let's move on, take a look at this demo about the social aggregation. And this slide, we have two graphs, the user item graph, denoting the interactions between the user and items, and the user social graph, denoting the connections between the users. And here, this rectangle indicates the feature information of a row. And we first use the item aggregation to learn the item space user latent factors in the user item graph. Then, the social aggregation is proposed to learn the social space user latent factor for the social graph. And this with rectangle is the social space user latent factor. We need to learn in this social aggregation. Except from the social relations, another important source we can use to benefit recommendation tasks is the knowledge graph about items. So in next part, we will introduce the knowledge graph-based recommendations. And a knowledge graph is a heterogeneous graph in which the node corresponding to the entities and age is corresponding to the relations. And in these recommendation scenarios and items, and can corresponding to a kind of entities in the knowledge here, and these knowledges then can provide the connections informations between the items via these different types of relations, and allow to capture the semantic relativeness of the items. And these connectors can be found as the tuples, the head relation and tail. For example, the tuples, the foreign grams, and the film and directors, and the Robert, and states the fact that the Robert is the directors of the film, the foreign gun. So the knowledge graph can provide the attractive source of relational information about the items, and can be harnessed to improve the recommendations. And the question here is how to capture both high order structure and semantic information in the knowledge graph. In this slide, we introduce a solution, the knowledge graph convolutional neural network, and end-to-end framework that effectively capture the inner item relativeness by mining their association attributes on this knowledge graph. And this work was proposed in W 2019. And this KGCN aims to automatically capture the both structure and the semantic information in the knowledge graph for recommendations. And to model this relation node heterogeneous knowledges. And they propose to use a trainable and personalized relational score function, G, the pi RU here, to transfer the knowledges into a user-specific relations. and which can describe the importance of the relation R to the user. Then to describe the topological structure of the item V, we compute the linear combinations of the item V's neighborhoods. This step can be treated as the neighbor aggregator. Finally, we further aggregate the entities representation, that is the cell representation and its neighborhoods representation, into a single vector to represent the nodes, the items representation, and made the prediction with the user representation. Another method is the knowledge graph enhanced graph neural network based methods, the KGAT, which was proposed in KDD 2019. So here, the KGAT incorporate the knowledge graph into the recommendation task. They consider the user node here as one type of entities, and the interaction between the users and items as one type of relations in the knowledge graph. So in other words, the KGAT integrates these two graphs, the user item graph and the knowledge graph, into one large graph. They turn this graph as the collaborative knowledge graph. So in such a scenario, they can form high order relationships between the users and items, an item and item, and the user and users, so as to implicitly model or explicitly model the high order relations in the collaborative and knowledge graph, and provides the better recommendation with these items inside information. Okay, as shown in this figure, the KGAT consists of three main components: the embedding layer, the attentive embedding propagation layer, and the prediction layer. So in the embedding layer, KGAT adopts a very classic knowledge graph methods, that is the trans R, which are formulated in these two equations. The main idea is to help learn each entities and the relations by optimizing this translation principle. Next, in the propagation layer, the KGAT used the knowledge-aware attention mechanism to perform the information propagation from the neighbors, and then update the node representation by the aggregation function. Here, we should pay attention to the knowledge-aware attention, in which they made the attention score depend on the distance between the head entities, EH, and the tail entities in the relation R space, WR, and to propagate more information for closer entities. And at last, the KGAT concatenates these embedding from the all layers to generate the final low embedding, and also use the inner product between the user embedding and the item embedding for make the final prediction. Now, we have already introduced two categories with some side information enhanced, like using the social relations to enhance the user representation and learning, and using the item internal knowledge to enhance the item representation learning. And so here the question is, can we unify these two categories and have a more powerful recommendation methods? The answer is yes. We here introduce a model called GraphRec Plus, which was proposed in TKDE 2020. In this work, they further consider the substitutable and complementary item to enhance the item representation learning in the social recommendation scenarios. For example, on some e-commerce sites like the Amazon or Taobao, they announce users to navigate between the products through a link, such as a user who bought product A also bought product B. User who views the product A also will view the product B. This paper actually extend the graph web model in social recommendations by incorporating this item graph for enhancing the item representation learning. We can see that the item modeling part is quite close to the user modeling. They also have two aggregation, like the user aggregation and the item-to-item aggregations. Okay, this is for the representative graph neural network-based recommender system. And in this slide, I just give some directions we can look ahead. And although we can see the power of the graph neural networks for the recommender systems, and we also have some challenges. The first challenge is that do we need the deeper GNN for the recommender system? Actually, we can find that the most existing GNN-based recommender systems can achieve the best performance in a few layers because of the over smoothing issue. So here, we still need to understand when the deeper GNN can benefit the performance of recommender systems. Second, recently, we find that deep recommender systems are vulnerable to adversarial attack, and the attacker can add some adversarial perturbation in the user item graph or the user social graph, so as to manipulate the user's decision. And this perturbation can be add some fake user item interaction and the social connection, and to perform the data poisoning attack. And one representative black box attacking method is the copy attack, which propose a copy mechanism to copy the user profiles from the source domain into the target domain. So it is necessary to build a robust graph neural network-based recommender systems against these kind of adversarial attacks. Okay, this is all my presentation. Thank you. In next part, Xiangyu will present the automatic machine learning techniques for recommendations. And another thing is we are looking for the self-motivated PhD student and who are interested in the data mining and machine learning. So if you can send me an email with your CV if you are interested.